Welcome back to the Clojure Koans walkthrough. Are you ready to learn about maps? Well, here we go. We're going to dive into number 5. And it's all about maps, apparently. What are maps? Okay, once again, we're going to quickly clean up the code here so we can play with it in Light Table. So here we got all the expressions available. This one's a little bit longer than the previous ones. Oh, it should be interesting. Okay, so there are two ways to create maps. You just call hashmap and you get back, what? Well, I think I'm going to infer from these later examples that the syntax for maps looks like it's using curly braces. Oh, sure enough, that seems to be it. So if you call hashmap function, you get back a map. And a map can be expressed with curly braces in Clojure syntax. Okay, maps in Clojure associate keys with values. Okay, keys and values. Well, what's the number of keys and values in an empty map? That must be about 0. Yeah. Okay, a value must be supplied for each key. Okay, hash map of A and, well, if it equals A and 1, then this must be 1, right? Yep, okay. So the map is associating keys with values. This map is associating A has the value 1. The keyword A has a value, is associated with the value 1. Okay. The size is the number of entries. Okay, so in this map that they give us here, it has A going to 1 and B going to 2. So that's 2 entries, 2 associations. Great. You can look up the value for a given key. Now this is cool. So we've got a map with 2 entries in it, and we're trying to get the value for the key B from that map. So the value for the keyword B is 2. That get function should return 2. And sure enough, it does. Okay, maps can be used as lookup functions. Okay, now this is getting a little bit weird. Clojure lets maps serve as functions, as lookup functions. So you pass as a parameter to this lookup function the key that you want to look up. So we're going to look up the keyword A, and according to the map, the value is 1. So it's very similar to calling get on that. In fact, I think it's identical. Okay, so we don't need to call get. We can actually let the map serve as the function. That's interesting. And you can think of maps as, yeah, they're basically functions. They map keys to values. Okay. Oh, now here's another weird part. So keywords, meaning colon and then some type of variable, type of symbol. This is a keyword, and they're a little bit special in Clojure. So keywords can also serve as functions. Okay, that's a little weird. It's kind of the reverse of what we saw above, and yet it's going to return the same value. So we're going to look for the keyword A from the given map, and the value for keyword A in the given map is 1. Cool. Okay, so don't let that confuse you just yet. But map keys need not be keywords. True. Okay, so look at this map. We've got numbers mapping to strings, or yeah, this is a number mapping to a string. That's a number mapping to a string. Same at the end. Okay, so we're going to look up the value for the key 2010. That would be the string Vancouver. Okay. Cool, that one passed. You may not be able to find an entry for a key. Okay, that's definitely common. So we're going to look for the value for the key C. Now, it's not in the map, so what the heck does it return? The only thing it can return, I think, which is nil. Okay. but you can provide your own default. So you can pass the key you're looking for to the get function, but you can also pass what you'd like to be returned if the key doesn't exist in that map. So in this case, C does not exist in the map. So the get function is not going to return nil. It's going to return back your next parameter here, which is key not found. Great. You can find out if a key is present using the contains function. So contains question mark. I guess this function is going to return a Boolean, true or false. And so we're looking for if this map has a value for the keyword B. And sure enough, it does have the value nil. But what's the difference between calling get and it returns nil because it's not there versus get that returns nil because the value was nil? You can't distinguish. So you need to have a contains function that will tell you if the value is there or not. So in this case, contains will return true. There is a value for B, and it just happens to be the value nil. Okay. So if it's missing though, if we're looking for C in this map, the get function would be returning nil. But the contains function will actually return something more useful, false. Okay. Maps are immutable, but you can create a new changed version. Okay, that's nice. So if we have a map of 1 to January and 2 to blank, then, okay, we've got this assoc function, and it's going to associate the key and the value that you give into the given map, I guess. So it looks like it's trying to associate the value February with the key 2. So this assoc function should not return back this map or a modified version of this map. It'll return back a new map that has this data plus the new value you're associating. So we should see 1 in January and then also 2 in February in this new changed map. All right, you can also remove an entry. Remove is in quotes because you're not modifying the original map. If anybody else had a reference to this map, it would be unchanging. Even though you remove an element from it, this map does not change. The remove function will only return a new version of the map that has the element missing. I shouldn't have said remove. This is actually the dissoc function, dissociate. So we're going to dissociate the key and value from the map for the key 2. So that leaves us with 1 mapping to January. Great. Often you will need to get the keys, which will be in hash order. Okay, so let's get the keys. We've got a function called keys that will, I guess, return back the keys of this given map. And so just the key part, so just the 2006, the 2010, and the 2014. And when we sort them, I guess we're going to sort them in the proper order, even though if you didn't sort them, you don't know what order it might come back in. It could be anything. You can't really count on the ordering because they'll be in hash order. Okay, so it looks like this one passed. The list with the 3 keys was our result. Or you can get the values. So the vals, that's Torino, Vancouver, and Sochi. So when we sort those values, it's Sochi, Torino, and the last one, Vancouver. Great. Wow, we did it. We're done. Not too bad. All right, now it's going to get exciting. See you in the next one.